when I look at example 7, I immediately know it's going to be a spiral. Okay, the spiral is really, really hard to graph using a table. Suppose you could use a table. You start plugging in whatever you want. You can plug in 0, you can plug in 15, you can plug in 30, you can plug in anything you want. But I think it's going to take you forever to really get a feel for what this graph looks like. So let's just go to Desmos again, and let's see what this looks like. It was r equals 2 theta in radians. Thank you. Okay, so notice, I mean, you really need to zoom out to be able to see what actually happens here. So it's kind of hard to tell, but 1, 2, 3, 4, 5, 6. It goes around like 6 times there. So, you know, are you going to be able to draw this? I don't know how accurate I'm going to force you to be, but let's just draw kind of a quick sketch, I suppose. But notice we have to go out to like 100, so let's change the scale. Okay, let's change the scale. And then we're going to go around 1, 2, 3, 4, 5, 6. That's not perfect. That's not perfect by any stretch, but I mean that's pretty much, you know, that's a decent indication of what it looks like. Okay, feel free to take your time and do a little bit better job, but I'm not going to force you to be super accurate on that. Okay, let's look at number 8. Okay, number 8. I bet you don't know what that looks like. Okay. They want us to convert it to rectangular. So every time they ask us to convert to rectangular, they're talking about x and y. So they want x's and y's instead of r's and thetas. Let's just type that in and see what it looks like first, though. 4 over 1 plus sine theta. Looks like a parabola, right? Looks like a parabola. And you can zoom in and you can tell that it has a vertex up here at 2, and it looks like it crosses at 4. So those are kind of its points of interest, I suppose. So it has a vertex at 2 and 1, 2, 3, 4. 1, 2, 3, 4. I can already tell pretty much what it looks like. Looks like a parabola. But they want us to convert, so let's convert. Okay. Basically what we would do here is we're looking for some way of changing into x and y. And so as you examine this equation, you see an r and you see a sine theta. Now they're not written together, but if you could piece them together, r sine theta would look like y. That's one of our conversion equations, so that would be useful if we could get r sine theta out of that somehow. Okay, and so I figure what we can do is if we look at this as a proportion and kind of cross multiply, we're going to end up getting an r sine theta. So imagine if we cross multiplied that, you'd have r times 1 plus sine theta equals 1 times 4. Okay. Distributive property, I'd have r plus r sine theta equals 4. So I can convert now because I know that r sine theta is equal to y. So I know that would equal y. I can do my conversion on that. But I've got another conversion for r because I know r equals the square root of x squared plus y squared. So we've got a couple of conversions we can do. And I know that second one, this one's kind of ugly. but we have the square root of x squared plus y squared plus y equals 4. At which point we really want the square root to go away. And so what I would do is isolate my square root. I'm going to subtract this y over. X square root of x squared plus y squared equals 4 minus y. And I can isolate the square root. I can square both sides to make it go away. So squaring both sides, I've got x squared plus y squared equals, and I'm not gonna FOIL that out. I'll just leave it as 4 minus y squared. Actually, let's go ahead and FOIL that out. That's going to be 16 minus 8y plus y squared. Once you FOIL that out. So we have x squared plus y squared equals that. And you would notice those y squared would cancel each other out. X squared equals 16 minus 8y. Or switch that around, x squared equals negative 8y plus 16. You're starting to look like an equation of a parabola. Okay, remember from Algebra 1 class, it always said y equals something x squared. That was always a parabola. Now this isn't quite written in that same form, but maybe from Algebra 2 or maybe from your college algebra class, maybe it was written in this form. But maybe if we factor out that negative 8, it looks even more so. If I factor out a negative 8, I would have x squared equals negative 8 times the quantity y minus 2. And so you can see from this equation, you can see the negative sign indicates it's pointing down. You know, this x squared indicates that it's a parabola. The negative that it points down. And, here you've got the 2 part of your vertex. And so, remember, in vertex form, actually, that wouldn't be over there. It'd be over here. It's like over here is x minus 0 squared. And so you can kind of see your vertex of your parabola. We're seeing a parabola that opens down, and we see a vertex of 0, 2. But wasn't it so much easier just to type it into decimals?
Yes.
Okay. We've got this same parabola, opens down with a vertex of 0, 2.